So today we have Russ Benton from Sheet Metal Workers. Hi, Russ.
Hi, Nita. Nice to see
Hi.
you.
Nice to see you. Let's get started.
Okay, so my name is Russ Benton, and I sit on the Joint Apprenticeship Trading Committee for the Sheet Metal Air Rail and Transportation Union on the sheet metal side, and we'll get right into our presentation. So let me start with a PowerPoint that I'll share right now. And okay. So does that come through, Nita? Is it loaded up on your end?
It is. I don't believe you're in. There you are. You're in the presenter view now.
Perfect. Okay. I have to adjust my laptop when I do it. Otherwise it looks funny. Okay. So let's get into it. Our program centers around career technical education, and the topics we'll talk about today are the college accredited associate's applied science degree that each one of our students is able to earn. We're going to talk about the career opportunities, the different jobs that are available. We'll talk about the tuition-free apprenticeship curriculum. All of our like I said before, all of our classes are 100% accredited through Mount Hood Community College. And we'll also look at some personal development, professional development that each one of our students is exposed to. So when it all started. So we just had our 133rd birthday on January 25th. And our organization was founded in 1888. So we've been around for quite some time. So the minimum requirements for applying to our apprenticeship, you need to be at least 18 years old. So if somebody has a birthday during the summertime, they'll be required to wait until they hit their 18th birthday. They need to have their high school diploma or GED, have completed Math 60 and Writing 101. And then each one of the applicants needs to sit for the Work Keys NCRC test and at least get to a silver level certificate. It's like a placement test that you would take at like a community college, something of that nature. So the minimum requirements to receive your associate's applied science degree after you can work towards this while you're going through the apprenticeship. So we'll look at those requirements. So they need to complete Math 65 through Mount Hood or another college that they could transfer their credits through, and Writing 101 or 121. And the reason they have two writing classes listed there is because it depends on which writing class that you had started with. So you'll be required to complete 3 extra credit hours of that, along with a human relations course and a health and PE course of 3 credit hours. So total 13 credit hours to finish up your degree. So our apprenticeship requires 1,000 hours of classroom academic time and hands-on training. And then they also require 8,000 hours of on-the-job training. So those have to work hand in hand. And that's the 8,000 hours they're required to turn in monthly progress reports so we can track that. Along with that, the students earn that, like we had said, they're able to earn their associate's applied science degree as long as they finish the classes that we had just spoke of. I'm going to move my window out of the way there. And each student is required to maintain a 2-point GPA at the time the degree is awarded to be eligible for it. And they'd have to anyway to be enrolled in our school. Otherwise, they would fail. So we don't want that happening. So our training centers, where are they located? We have 2. So the first one, our main office, is located in Portland. We currently have 350 students enrolled, and they're split between both of our training centers. As you see, we have hands-on shop classes that the students are required to do, along with the academic in-classroom stuff. And we'll take a look at what the curriculum looks like for each one of our students. And the other training center is located right here in Springfield. And again, it's the smaller of the 2, but structured very much the same with the hands-on and classroom time as well. All the same requirements, 1,000 hours, along with the 8,000 hours of on-the-job training. The class schedule, how is it structured? So what are the students required to do? What's that look like? So each student is required to attend class for 5 weeks per year. And each time they attend class is 40 hours per week. So it's like they start Monday morning And then they go to class 8 hours each day, Monday through Friday, and they return back to their jobs the following Monday. And this will go on for 5 years, and that will equate to the 1,000 hours of classroom and hands-on training that they would receive at either one of our training centers. And they are also eligible to collect unemployment benefits because obviously they can't work and go to school at the same time. That wouldn't, you know, who's going to work 80 hours a week? So that's a nice thing. And also, each one of the students averages 1,750 on-the-job training hours. And the reason why that number is what it is because you have to subtract out, obviously, the 5 weeks of training they have per year, along with, you know, holidays and things of that nature. So a 25-week snapshot. So let's kind of look at what each student has to, what classes they're going to be enrolled in. So we are heavy on the math, you know, probably not a big surprise being in the construction industry. And then we get into some of the techie stuff, like the drafting, parallel line development, radial line development, triangulation, blueprint reading and job specifications, calculator layout, the HVAC duct design, which is super important for efficiency, along with the tab testing, adjusting, and balancing. We have a standalone service apprenticeship, along with our building trades apprenticeship. So we actually have 2. And then also, you know, AutoCAD detailing and our leadership skills. The classes are the foreman classes that each one of our students are eligible to take. We want them to be successful. Sky's the limit. And here's a snapshot of the service program itself. So as the students are able to look through this, they'll see that this is what the more techie side of our industry. A lot of anything that has to do with the controls, maintenance, or repair of any HVAC equipment that's going to be found here in these classes. And here is the rest of that service class schedule. So our apprenticeship classes, what are our students required to take? So obviously, like I said, we're heavy on the math. So your students occasionally will ask, you know, when am I ever going to use fractions after I graduate from high school? Well, we can't get away from it. We use it every day, along with some of the other math that we'll get into just here in a minute. We also get into tool identification, so they know the proper way to use the tools and what they're used for. And these are just some simple hand tools that we're showing here, some basic stuff. But they also get into power tools as well, and the equipment that are going to have to be around and use. Safety is a big, big thing for us. We want to make sure that everybody goes home just as healthy as they did when they arrived the first thing in the morning. So each one of our students is required to complete a NOSHA 30 class, along with the first aid and CPR. We take the safety, we can't take more seriously. It's just a part of our culture, and it's something that we believe firmly in. We want to make sure everybody's safe, and it's just the right thing to do. So thermodynamics, there's a $10 word. So what is thermodynamics? Well, let's check with NASA and see what they had to say. Okay, so it's heat transfer. Super important. Heat transfer not only helps with building efficiency as far as keeping the temperature of the air from point A to point B, maintaining that temperature, but also without the correct insulation around the ductwork, you can actually create a water leak inside of a building without any rain, just due to condensation. Running really cool air during the summertime through metal ductwork can create condensation and create drips inside the building. So, and also for efficiency, you don't want equipment overworking itself, trying to maintain the temperature of an occupied space due to heat loss from the transfer from the equipment to each one of the rooms in the building. So super important for efficiency and to maintain the temperature of a building. Let's get into, so electrical fundamentals. So this is geared more towards the service side of our industry. Each one of the apprentices that are going through our service classes, they're able to sit for their limited energy class B electrical license. And this would occur right at their 4,000 hour mark of on-the-job training. So they would be, the state of Oregon would allow them to sit for this license at that point. Math, yes. Geometry, when are they ever going to use that after they graduate? Well, in our industry, we can't get away from it. Everything is a geometrical shape, everything. Algebra, again, every day, we can't get away from it. Trigonometry, we have really cool calculators now that do a lot of the hard work for us, but you have to have a really good foundation of how to get the answers. You're always required to verify the numbers just to make sure that they are correct. So parallel line development, radial line development, and triangulation, what does this look like? Well, here's some examples of what you would find if you were in our program. And each one of these items is a hand-drawn depiction of an actual fitting or a piece of material that you would use in a building. We're one of the few trades that actually still has to construct each one of our components. A lot of our building trades affiliates can buy their materials from a parts warehouse, things of that nature. But we still have a lot of hands-on built items that go, and they're usually custom built items that go into a construction project. And generally they are custom to that room, to that project, and they can't be used elsewhere because of the size and shape, etc. So yes, and you never forget it. It looks complicated, but once you learn it, it sticks with you. Welding and fabrication. So another part of our industry that the students are required to learn. The photo on the left there is of a squared around, and that would be the triangulation formula that we just looked at. And the one on the very right, the round piece of pipe with the saddle tap on it, that would be parallel line development, would be used to actually create that. And in the center there, that is our Secretary of State, Shamia Fagan, brushing up on her welding skills at our Portland Training Center. So geometrical construction, again, very important. Shapes, area, angles, you need to be able to calculate all these. These are all skills that you have to be successful in our industry. And in a lot of cases, buildings, the architects are very creative, and they have a funny way of creating buildings with no straight walls in them. If anybody's been out to the Nike campus, you know exactly what I mean. But super important to verify the location of different items in a building and to be able to calculate the cubic feet per minute of air change in a room, etc. So understanding airflow. So what are the best practices for this type of stuff? All of these things are taught in our training center. We want our students to understand what's the most efficient way to install and design and draw up and detail any type of ductwork that they're involved in. And so the bottom picture there in the middle, it shows best practices, kind of the do's and don'ts of our industry to get the most efficient system that you could design given the situation that you're in, and very important for the customers and the projects that you'll be working on to be able to recognize those things. You want to have a good foundation of this stuff. Blueprint reading. So once upon a time, it was all rolled up paper and a lot of lines and things like that, but we're slowly moving away from that. The picture on the right there, that's actually Bluebeam. And one of the projects that I was on, one of my last ones, used Bluebeam almost specifically because they're going so paperless now. Things actually can change and happen in real time. And it helps with tracking as well. And those students are also, so this is all part of what they will learn. That the picture in the center there is of a legend of one of our blueprints, and shows all the symbols and things like that, so that students can understand what it is that they're looking at, and so they can read their blueprints. And so work ethic and leadership. So as I mentioned before, we have supervisor training through our foreman classes. The work ethic, each one of our students is required to sign a code of conduct. And that simply means that you'll show up on time, your attendance is good, that you'll be working drug-free, and that you put in a good day's work. And we want to make sure that everybody's successful. We don't want somebody falling behind because of their attendance. So the career pathways. So what types of jobs are out there in industry available for the students? So let's take a look. So here's a short list of some of the careers that the apprentices are able to enter into. Of course, the building trades, HVAC and architectural installers, the service technicians, those three are kind of the dominant industries that we revolve around. Of course, you can't have any of those facets of our industry without having supervision, the detailing, the BIM, Trimble, AutoCAD, and Revit. And I'll get into some examples of that later, along with the tab, testing, adjusting, and balancing, super important for efficiency, production of the sheet metal fabric. So we'll look at the production industry and what that entails, the industrial fabrication and welding, project engineer and project management that deals mostly with budgets and scheduling and things like that. So the HVAC installer. So we'll run through a few examples here. So this is this makes up about 60% of our industry right now. And we'll go through a few different examples. So we have different types of ductwork and different settings. There's a lot of different facets to this type of our industry. This is where most of our apprentices, this is kind of the market that they dwell in for their employment. That last photo was actually a system that I designed myself out in North Portland. But as you can see, it's all about, most of the stuff has to do with transferring air to occupied spaces from equipment from one location in a building to another. So let's look at the architectural. This would be the building envelope, the exterior of the building. So some of you may recognize this. This is the Pop Culture Museum in Seattle near the Space Needle. Our affiliates to the north actually installed all of this exterior paneling on the Pop Culture Museum there. And so these are examples of the architectural industry and what our architectural installers install and work on. It's all exterior panel systems, as you can see. And we also did at University of Oregon, the big tower with the cool little markups of all the athletes on it. That was done by Bassett Construction. And that is all considered architectural work as well. So service technician, the other standalone apprenticeship program. So service tech is the techie side of our industry. And this is a lot of the controls and repair and maintenance of equipment. Super high demand, typically pays more than the other facets of our industry because of the need for those types of folks. And this is not just for the boys. This is not just for the young men that are getting ready to leave. We have a rapidly growing number of women that are joining our trade, and we're hoping to increase those numbers. And we encourage all of them to look into doing this as an option. We understand that a lot of people don't have the resources or the desire to do a traditional four-year university. So with that being said, this is a great alternative. And that little silver thing there in the middle, next to that guy's hand, that is a capacitor for that piece of equipment. Just a coincidence that I know that. I am not a service guy. So BIM, AutoCAD and Revit, what is that? Building information modeling. So this is kind of the cool high-tech side of what we do. Nowadays, you're able to actually take a virtual tour of any building prior to it being constructed. And the reason for that is you're able to identify any issues that may arise. If there has to be a change in the size of a room or the configuration of a mechanical system to make sure it's working properly or efficiently, or there's no conflicts. This can happen months, even years before the building actually goes under construction, and those can be addressed and corrected. And a few more quick slides of the BIM and AutoCAD. So the virtual setting of the building is very cool. You can actually strip away different layers of the building, so you can actually look and see the actual components, the working parts within the building, and to see, are they going to be working correctly? Are they going to fit in the space that's allowed? They always try to jam as much as they can in. And it shows every little detail. If there's going to be a clash, will the system work properly? And they miss nothing down to the size of the nuts and bolts that hold all the whole thing together. It's all drawn in here. And you can strip away the roof, the flooring, see the mechanics underneath, see how it all works. Testing, adjusting, and balancing. So really crucial and important for indoor air quality. And we know that this has effects on a bunch of different facets. Especially with things going on now with COVID-19, indoor air quality is super important for the infectious disease spread, eliminating that with the wildfires, eliminating the smoke infiltration for buildings, things of that nature. Industrial fabrication and welding. So some of you may recognize this first picture. That is actually the tower at Oregon Health and Science University that supports the Sky Car that runs up to the hospital and back down to the parking lot. And that was actually done by Thompson Metal Fab, one of our contractors. And this other one on the right here is a large stack that was done by our affiliates to the north in Seattle area. Project management and project engineering. So this is the numbers side. This is the budgets, the scheduling. These folks they deal with the architects, they deal with the general contractors, they deal with the customers to make sure things are built on time and within the budget. And this is also kind of a niche part of our industry. We can't have any of it without these folks. So it's super important. But these are the ones that are in the office quite often, on the phone constantly, answering emails and making sure there's no issues that need to be resolved. If there's any change orders or requests for information or extra services that need to be charged, these would be the people that would be taking care of that. Schedules, making sure everything is done within the schedule that's allowed. They see these types of things quite often. It's one of the primary pieces of their work. And they look kind of a big picture as a whole. They will actually look at the entire project and look at the end result and work backwards to make sure that the schedule will work out and they have enough time for each phase. And that was the end of that PowerPoint. So thank you very much for listening to me ramble. And I will share whatever PDFs I have with some information with Nita, and she will be able to share it with the students. And so our program, and I'll stop my screen share, our program actually, if you look at the college credits, it's a $25,000 free education is what it is, along with being able to work at the exact same time and work towards your associate's applied science degree. Unfortunately, the last 13 credit hours are the responsibility of the student to complete, and they can do that while they're in the program. But that's kind of where we're at with it. So normally I would ask for questions, but we'll do that later.
I think we're going to have just a second for our student to ask a question. I'm going to quit recording. I want to say thank you, Russ. That was incredibly interesting. And especially, I was thinking about what you said about the air quality on multiple different fronts being so important right now.
Yeah.
So yeah, just kind of hit home. Anyway, I'm going to stop recording and